right? We'll come to it in a moment. Now this satellite, why I'm showing the satellite, as far as industrial growth is concerned, remember, it doesn't take place on just isolatedly. There should be big projects in that a visionary should consider, and based on such big projects, the project breaks into small and smaller projects, and every project, every smaller project creates a kind of industry. So in India, this ISRO has really worked in that direction. The requirements of ISRO, they motivated many other industries to grow. For example, in the earlier time, the steel industry in India grew because the Britishers required steel for making their tanks. So that motivated. So and then it started long back, and it still continued. So we see that big projects which are important in actually creating the proper environment of industrialization and industry requirements. So this is one of those projects. I am going to talk few like this, and then we'll go ahead. So what do we see? This name, it was named after Bhaskara, the Aryabhatta, and Aryabhatta is the great mathematician. Another name which pops up is our late president, Dr. APJ Abdul Kalam. He is always associated with any space mission that we have. And why? We'll see it in a moment. Well, so this story, this Aryabhatta satellite, it was launched in 1975 with the help of Soviet Union rocket from Kapustin Yar. It was again from the Soviet Union. It was not Russia, it was still Soviet Union in 1975. So you will see the rocket was borrowed. The satellite Rohini, it was launched in July 1980 by SLV-3 vehicle from Sriharikota, India. Now this is where the industry came in. We didn't have rocket earlier. To make a rocket, you require certain chemicals, you require certain kind of alloying, you require certain kind of electronics. All those things were slowly started developing, and corresponding industry got developed in India, and that's why such a rocket was possible. Please remember that as far as rocket and atom bombs are concerned, nuclear energy, not a single country will come and help you. No way. They will never share their knowledge. In this respect, you have to build it yourself. And we did it. This is where the success story of space mission began. This SLV-3 was the product of dedication, planning, and perseverance by Dr. APJ Kalam and his team. Salute to them. Look what was the situation at that time. You will see that these rocket parts were carried from a bicycle. So we really were so much in want of so many things at that time, but out of such a very difficult situation, Dr. Kalam actually built a working rocket which took the first flight and successfully put Rohini into space. So the Indian National Committee for Space Research, this was established in 1962. It became Indian Space Research Organization, that is ISRO, in 1967. The first director was Dr. Vikram Sarabhai, a great visionary. The present director is Dr. K. Sivan. Probably you must have seen him during the Chandrayaan mission. So where do our satellites get developed? They are developed at Space Application Center, or SAC, at Ahmedabad. Remember, all these developments actually initially work in a laboratory, and all that technology is given to industry, and industry is developed. So all such projects are absolutely important in any country if you want to do the industry development, because the industry is just an offshoot of such big projects. You must have seen that large accelerators are built in various countries. You will know that lot of industries built around those particular accelerators. So growth of industry depends upon what projects you take in your country on a larger scale. Now, SAC, it is a center established under ISRO. The first director was, of course, the director Dr. Sarabhai. And then we always ask the question, what was the role of Dr. Kalam? Dr. Kalam joined Defense Research and Development Organization, DRDO, in 1958. And then he moved to ISRO after it was established as a project director of Launch Vehicle SLV-3. SLV-3 stands for Satellite Launch Vehicle, SLV-3. So he was the project director of that first rocket. And he carried out various experiments, and after successful experimentation, this experience helped him to develop many missiles for defense application, and that is why he earned the name the Missile Man of India. Another great technological leap of India is in the use of atomic energy. Dr. Homi Bhabha, he was an illustrious scientist from India. He was known in the international science for his novel scattering theory known as Bhabha scattering. This was nuclear scattering that he worked on. He conceived the idea of use of nuclear energy for good of the society in 1945. This is before India became independent. So he established Tata Institute of Fundamental Research at that time. For a full-fledged nuclear program, many technologies were needed. Therefore, for this purpose, Atomic Energy Establishment Trombay was established in 1954. However, after the sad demise of Bhabha in 1966, it was renamed after him, and now it is known as Bhabha Atomic Research Center, that is BARC. So you can see the establishment of BARC has given rise to a very large number of industries. Today, many industries that you see in Mumbai, they are around this particular project. In fact, you are now in MP, and I remember BARC has CAT also established there. Around CAT, there are many industries. So do observe that how large projects actually help creating different industries. And this is a very good news for us. In July 2020, very recently, few months back, a 700 megawatt, 100% indigenous nuclear plant became operational at Kakrapar, Gujarat. This is a big achievement towards self-reliance. Remember, today we are buying nuclear plants from Russia or France. They are 3000 megawatt. We haven't reached 3000, but we have reached 700 megawatt after 70 years. So you can see that these are things which nobody will share with you. You have to develop yourself, and while doing this, many industries have been benefited. This is that Kakrapar place where it is shown. Bharat, our country, has developed nuclear weapons as deterrent against expansionist countries in our neighborhood. You know which are those countries. And these nuclear warheads, this development is totally indigenous. From plutonium-based small nuclear weapons, remember, you don't have to have very large atom bomb every time. You can have very small nuclear weapons made from plutonium. And the large one is hydrogen bomb or thermonuclear weapons. These are 10 times more intense than normal atomic bomb. These are developed. Only other 5 countries have thermonuclear weapons, and India is one of them. India is the 6th one. So you can see all these are developments. How we can do, the scientists and engineers both work together to develop the technology. And this is what is the crux of development of real good and reliable industry in any country. There are many more such institutes contributing to the technology development, and now I can certainly name Hindustan Aeronautics HAL. They have developed Tejas, a light combat fighter plane, one of the real good one in the world. Dhruva, helicopter for rescue missions. Indian Railways, they have developed 12,000 HP electrical locomotives now made in India. Various parts of bullet train are also now made here, and Bharat Heavy Electricals Limited is ready to manufacture monorails in India. So you can see that how industry is going. When you have a vision where you want big projects in your country, then your industry gets the boost. And some of you should be doing that also. So some people from you should be advisors to our uh, governments, and they should advise them correctly so that our industrial growth sustains, and it should be a sustainable growth without disturbing the environment, of course. Tata and Mahindra are already producing now electrical based vehicles. Today, our country, Bharat, has developed missiles having range up to 8,000 kilometers and capable of carrying nuclear warhead, which are very lethal. Remember, increasing the length, you have to change the technology of this particular rocket. India has developed it itself, and that's why we can send to the moon, we can go to Mars, we are able to do many things in satellite launching. So here, this is what is happening. Our developments, look at today's development. The very first satellite was built with 80% imported parts. Today, it's hardly 5 to 20%. So this replacement, which has taken place, is due to growth of the industry here. DRDO has developed many types of guns, tanks like Arjun, Bhishma, armored vehicles, floating bridges, surface-to-surface and air missiles. Dhanush, Howitzer, K9 Vajra is
Sir,
one of the
sir,
best.
sorry to interrupt you. Sir, Ankit, I have told you guys not to start presenting. Sir, you please resume the presentation. Ankit Patidar, you guys have now spent 5, 6 days. You should learn this small bit of technology. You are going to be the future engineers. Yeah. Sir, kindly resume the presentation, sir.
I will go back. I will go back. Just a
Uh,
moment.
sure, sir. Students, not click on the button or the touchpad wherein it is written present now. Do not do that, or else the time is limited. If you are doing that, I do not need to repeat who is going to be the at the loss. Thanks, sir.
Okay, it's back. Is it coming back?
Yes, sir, it's coming back.
Can you see the screen now? Hello,
Yes, sir,
can you?
absolutely.
Yes, sir.
Yes, sir, absolutely. We can.
So we were here, we have developed our own unmanned air combat machines capable of long range surveillance and attack. Because we have developed our radar technology to such an extent that we compete with anybody in the world. So this is also possible, for example, due to a very large project. You perhaps have heard the project in Pune. This project is on the large radio waves detection. It is actually a scientific project, but in that respect, we have actually developed many detection technologies very useful for the radar. Development of Ariane class nuclear submarine. This is one of the most talked about event. Do you know that this particular submarine cannot be detected? And that is the reason why our neighbors are very fearful about it, because they cannot detect it. And it is capable of sending nuclear missiles. So such developments are possible on our own because our industry supported it, and industry was supported because of these projects. So this is a kind of non-linear relationship, but on the growing side. So that's very important. So we see that these developments come with a huge creation of indigenous technologies. By the way, just to give an idea, to develop Arihant, our scientists in BARC worked 30 years. One group, they never looked at anything else but just worked on this for 30 years, and it was developed. There is some kind of training given by Russians, but many of the things just came from our own scientists. The development in medicines and medical facilities has been one of the best in the world. The capability of India to face any epidemic, it is now shown here. Today we are facing this COVID-19 pandemic. There was only one testing center beginning on March. Today there are more than 2000 centers. And do you know how much time and details are required in order to set up one center? Because it is a very important and very hazardous thing to have such a center. And we are able to do on our own. The Serum Institute in Pune manufactures vaccines which are supplied to other countries as well. It is one of the largest uh, manufacturing units in Asia Pacific. And there are many companies who are manufacturing medical instruments like X-rays, surgical monitors, and so on. Well, all these developments are possible because of the right training imparted to our technologists. And what kind of training it is? Yeah, that's the question he is also asking. What kind of training? Well, now I am going to refer to a person who has changed our lives. Probably you haven't heard of him. Most probably not heard of him. Well, no more secrets. Here he is. Every engineer and scientist must know this person, John Bardeen. He invented transistor along with Shockley and Breton. He was conferred Nobel in 1956 for this. Another Nobel in 1972 with Cooper and Schrieffer for giving the superconductivity theory. So what do you see? A person who had changed our life by transistor invention, you know how the things changed. So many different devices came into picture, solid state devices, ICs, and so on. Of course, we have seen even a Nobel Prize given to the first engineer IC who has created IC sometimes back. Nevertheless, he was John Bardeen who did all this. Who was John Bardeen, by the way? Professor Bardeen represents an ideal technology person today. He did his BS from Wisconsin electrical engineering. So see, his basic, वो तो electrical engineer है. He then worked on antenna radiation and sea mine detection. He then focused on physics. He honed himself in both engineering and physics. It led to the famous invention of transistor along with detailed understanding of semiconductors which helped development of so many devices. The kind of training is well balanced in science and engineering. आप लोग तो इंजीनियर होने वाले हैं और कुछ समय ऐसा था जब इंजीनियर बोलते थे अरे साइंस की हमें क्या जरूरत है, साइंस तो एक बात है, इंजीनियरिंग दूसरी बात है. ये ऐसा नहीं है. अगर आपको इंडिया को उसी तरह बनाना है जैसे हमारे इसरो और बीआरसी के लोग बना रहे हैं, तो आपको साइंस उतना ही अच्छा करना पड़ेगा जितना तुम्हारा अपना इंजीनियरिंग करोगे. ये दो डिफरेंट चीज है ही नहीं. So that's why it says an engineer must know enough science to understand scientific problems in his engineering work. And a scientist must understand the engineering problems in his scientific experiments. Without this, they really cannot work. And by properly amalgamating both, you can become a very good technical person. So science, I do not only mean physics. People, depending upon where as an engineer you are going to work, you may have to know languages. If you are excuse me, a computer scientist, business strategies, you may have to work on chemistry, you may have to work with biologists. You should know enough science. So be attentive to science, don't neglect science, and that is what I would really like to emphasize for all of you. आप लोगों को करना ही चाहिए अच्छा साइंस. No, हम होता है. It is possible because of such people like Sarabhai, Govind Swarup, Homi Bhabha, and many engineer scientists who, refusing the lucrative offers from abroad, dedicated their life for their country. I know Professor Govind Swarup himself. He was a FRS and the person who did the world's largest antenna system. He was offered at Stanford a good position in 1958, but he refused. He came back and developed all today's radar technologies because of Professor Govind Swarup. And he developed it here, and that's why a large industry developed around it. So such people are there who dedicate, they learn and dedicate the life for the country. That's why it became possible. Well, what is the direction? So we have seen what is the today's scenario, what we have done. Then what we need to do in the future, that's where you people will be working, right? So that's why there are few suggestions, they are not exhaustive. तो आपको कुछ चीजें मैं बताऊंगा, कुछ और जरूर रह जाएंगी, लेकिन you can find out what others are. But these are some examples where we require it. Normally one would say that try to replace imports by indigenous products. ठीक है? So this is a big challenge. Technologies are developed through lot of research. It is not wise thing to reinvent the wheel. Hence, new technologies be developed in collaboration with our friendly nations like Israel and France. One, integrated circuit fabrication. Today, India doesn't have any IC fabrication labs. We have many designers, IC designing, VLSI designing is a basic part of integrated design fabrication. However, the final fabrication requires a fab lab, if you have heard this name. There, that is where actual IC is made. Secondly, not only IC, but you have to do contacts to the IC, bring the contacts out and make it more sturdy. All those technologies also are very important. That is called packaging. Raw material for solar cells. Today you have heard we make solar cells, true, but we don't make the raw material yet. The silicon of that kind of quality and that large number we require. We should focus on that. Large scale batteries, flow type and lithium ion. Remember these two batteries, flow types, very important because flow type batteries today, they take little more larger space, true, but you are able to make them with complete indigenous material. For example, iron based material, you can make good flow type batteries. Lithium ion you will require because in the coming years all the electrical vehicles will be using them. So we need to develop them here. Unfortunately, India doesn't have lithium, and that's why there is this dependence. So my own personal suggestion will be you should work on aluminum air batteries. Aluminum is amply available. There are difficulties, but one should work on that, or magnesium ion batteries. They are also possible in India. Missiles with longer range. Yeah, we should be able to go. We should be able to reach US. Why not? It should be intercontinental missiles. But people are already working. Hopefully, some of you will be working there. Advanced aeroplanes, passengers and fighters. Tejas is still the third version. We need to go to fifth and sixth version. So that's where research is required. It has to be done in electronics, it has to be done in communication, and it has to be done in very sophisticated mechanical engineering. Agriculture, food enhanced production and preservation. So how to preserve? Now there is a lot of requirement for agricultural products which are coming in on large quantities, but our capability to preserve is less. So food production, food based, how to preserve it in different forms, those are the technologies which we have to either adopt or develop for ourselves. High performance supercomputers, HPSCs, these are to be built on our own. Yes, CDAC is making, for example, in Pune, CDAC, the Center for Advanced Computing, it is there. And it is making these computers, but still it is not as good as those made by the IBM, but we will go close to them. We should go too close to them. High-speed transport on air, water and land. So all these are the big projects which will drive our industry in the coming future. Who are the industry drivers? Today, in the 20th and 21st century, Tata, Mahindra, Kirloskar, Birla, Garware, Ambani's, Mittal, Sanghvi, Nadar, Bajaj, Firodia, and many more are there. So they are the drivers of our industries. In 19th century, okay, so now I have started going back and back and back. Okay, let's go back. In 19th century, Sir Jamshedji Tata and his son Sir Dorabji Tata, I think these two were the prominent industrialists. What was situation in earlier centuries? Was there any industrialist or not? So this is where now we start going into the past of our country. After 19th century, in 18th century, well, there could be any name, but I don't know. I couldn't find any name. And what was happening? Where was there any industry at all or no? Well, there was production of weapons, utensils, agricultural products, and many more. So there was a continued production. However, it was not on a large scale. The small scale industry in Bharat, that is our country, was active for more than 4,000 years old. Okay, so look at our past. Why I say that you people, I mean all of us are capable of doing whatever any country can do, because it is in our genes. We can do it because look at our past. 4,000 years old in Sinoli. Now I am giving you what is archaeological data there. In Sinoli UP, excavations obtained chariots and copper weapons. That was the Bronze era, actually Copper era. Copper was slightly earlier than bronze. This was about 4,500, that is 2,500 BCE. BCE means before current era. And today we call CE, means current era. Today's is 2020 CE, means current era. So what we see that the metallurgy was much older than this time in Bharat. We had metallurgy much earlier. So it was going on. So there was industry, definitely. But we don't know the names of those industrialists at that time. India traded metal-based weapons and other tools with outside world for more than 3,000 years. Excavations in Bageshwar in Uttarakhand suggest iron use in 2500 BC in India. Can you imagine? Our people were using what? The iron. Particularly weapons and agricultural tools made from iron and steel were traded with Egypt and Rome. Well, wood steel from which the famous Damascus blades were made. You see, the name is Damascus blade. But who made that steel? In fact, it is derived name from Kannada word ukku, meaning crucible steel. Literary accounts suggest that steel from southern part of India subcontinent was exported to Europe, China and countries in the Middle East. So you can see this so-called this particular Damascus blade, the steel was made in India. And how that was made, why this is different? Remember, the technology of this particular blade is, it contains, now today we know the nanotechnology. This steel contains nanoparticles of carbon. As a result of which, the brittleness of this steel is reduced. It becomes sharp, it becomes very hard, but at the same time it is not brittle. It is very hard and at the same time it is fairly elastic. And this property is given it because of the nanoparticles. People didn't know that, they didn't know what was nanoparticle at that time, but they certainly had invented in an empirical way a method by which they could make. The most outstanding example is this iron pillar at Delhi. Some of you might have seen it, right? It is still standing there after 1500 years without or with a very small. This is that pillar. You can see, you must have seen it earlier. Wrought
there is some disturbance with Ghaisas network. Students, stay connected. Yeah.
Hello, can you
Yeah,
hear me?
sir. Yes, sir. Yes, sir. Sir.
Okay.
Now it is
Can you
clear.
see this? Can you
Yes,
see?
sir. Yeah. Wrought iron pillar. Yes.
Okay. So the iron pillar, this was originally established in 402 CE. It was in a Vishnu temple as a Vishnu Dhwaja, which is in honor of Lord Vishnu atop Vishnu Upada, a small hillock at Udaygiri in Madhya Pradesh. It's in your place. You must be knowing about it. By Chandragupta II. This was there by Chandragupta II, who ruled between 375 CE and 414 CE. It was later removed by Sultan Iltutmish in 1233 CE from its original location to which it stands today within the Qutub complex in South Delhi. So it was this Sultan destroyed the temple. However, he couldn't destroy this. Probably he thought that this is what is a kind of thing he can carry as his whatever he has won. So as a some kind of citation that he won over, he took this and placed it at Qutub complex. Now the chemistry is very interesting. What is happening is because of presence of 1% phosphorus, which is present in this particular steel, the reaction chemistry on the surface of oxygen changes. So you see, effect of impurities is very important in metallurgy. And when surface has little impurity, the chemical nature of the surface changes drastically. And this is what is very important, and we see it here. I don't go into details of how that layer is developed. The chemistry is very well known. But today, still we are unable to exactly produce the same kind of steel. So you can see the ingenuity of our engineers at that time. All over the world. Now we will come to gold, silver, etc. All over the world, this gold was observed. Gold sheets were found in cemeteries in Bulgaria dating back 5th millennium BCE. The uniqueness of our country is that wherein all other places gold was recovered by panning alluvial sand from deposits. You see, gold doesn't react with anything else. So what happens? It remains in the sand as a gold. It doesn't get oxidized. Most of other metals, they get oxidized in the earth crust, but gold doesn't get. But it is still embedded in different kind of sand. Therefore, gold particles are there which are in the same chemical form as a gold. So what they do, that sand mining was done. This sand is used, and this sand is used with some water, and in a way, in a different filtration way, you get the gold out of this sand. But in India, mining was done. In fact, very deep mines were found in Maski region of Karnataka. Also, अब ये देखो, ये तो बहुत इंटरेस्टिंग चीज है. हाँ, मरमट इज ए काइंड ऑफ रोडंट. ये अपना रोडंट जो रहते हैं जैसे rats and so on, they are all rodents. Marmot was a rodent in Afghanistan. It was used to bring the silver and gold containing sand near riverbed by digging in it. Now, how they must have trained it, I don't know, but this is something that has been mentioned. If it is really true, then it is fantastic. The importance of early Indian metallurgy is that zinc mining, production of zinc and related alloys. भारत में पहले जिंक बना था. हमारे पूर्वजों ने पहले जिंक बनाया, किसी भी देश ने नहीं बनाया. शायद आयन भी हमारे ही पूर्वजों ने बनाया पहले, नो डाउट अबाउट इट. जिंक बनाया. जिंक के बारे में प्रॉब्लम है, लोगों को प्रॉब्लम दिखाई दिया, इसलिए nobody can deny that India is the first one to make zinc. Zinc smelting is difficult as the zinc volatilizes near the same temperature of smelting of its ore. This would lead to oxidation of zinc and the smelting becomes useless. Smelting में क्या करता है? you have a carbon mixed with the ore, और वो जब हीट करते हैं तो ओर में से ऑक्सीजन कार्बन निकाल लेता है, एंड वो हाई टेम्परेचर रहता है जहाँ पे वो मेटल मोल्टन फॉर्म में रहता है, और ऊपर स्लैग रहता है जो रिमूव कर दिया जाता है, और तुमको मोल्टन मोल्टन मेटल मिल जाता है। लेकिन जिंक का क्या होता है, वो मोल्टन नहीं रहता, वो वेपराइज ही हो जाता है। इसलिए जिंक बनाना बहुत डिफिकल्ट बात थी। तो ये जिंक बनाने का उत्खनन में मिला है थाउजेंड्स ऑफ ईयर बैक। कहाँ मिला? झवर एरिया, दिस इज राजस्थान में है। इट्स अ वेरी लार्ज स्प्रेड ऑफ एरिया वेयर सच काइंड ऑफ थिंग्स आर obtained. In India, there is a unique evidence of extensive semi-industrial production of metallic zinc in Zawar. An ingenious method was devised of downward distillation of zinc vapor formation after smelting zinc. So this is what specifically it has been said, uh, so that this melted zinc vapor could be drastically cooled down. So I will just show you what is it. You see, this is where that zinc ore is fitting. This is the oven, and it is downward. There is a filter in between, so the the ash wouldn't fall down. But here there is a coolant. Actually, a coolant is from outside. So the vapor goes down and condenses, and this is where the zinc gets formed. So this is how the typical Indian method of zinc production is shown. This is very schematic, but you can see there is bellows, and it is very schematic way of showing. But this is what this is the ingenuity of our scientists and
Sir,
engineers.
sir, sorry to interrupt you in between. A very interesting
Yes,
question popping up from
yes.
Naved Alam. Sir, do we know the name who has made the jink? So
Unfortunately, no. These people are coming 4,000 years back, and they never took credit for anything probably. In fact, the whole point is, in India, writing started 500 BCE, and we're talking of 2500 BCE. From 2500 BCE, I mean, for all that long time, we were हम श्रुति और स्मृति इस पे रहते थे। स्मृति यानी जो दिमाग में रहेगा वो बाद में बोलेगा, बट श्रुति इज द वन जो अच्छी तरह से सुनने का, वो वैसा ही टेप रिकॉर्ड किया ऐसा सुनने को मिलेगा, यानी यू रिप्रोड्यूस एग्जैक्टली सेम वर्ड। इंडिया में जो वेदास है, वेदास आर कॉल्ड श्रुतिस। वेदास देयर pronunciation, whether it is in Kashmir or it is in Kanyakumari, they are exactly same pronunciation. So therefore, there is no, whatever said in Vedas has been preserved for thousands of years. But many things which are given, that we see now, those things like zinc production, etc., we really don't know the names of those people. Very difficult to believe who was that person. And still, how does it now matter? I mean, there cannot be his picture or anything to really. But anyway, interesting point. Maybe somebody should look into it into details. Some name might pop up.
sir,
Thank you.
may I interrupt in between? So, sir, what I was asking is it like can the students interact with you in between, or because we are almost towards the end of the session, so or you would like to conclude to something and then we will start that. So,
Able to hear. I'm unable.
sir, you are not. Is there some disturbance from that
Okay.
side, sir?
Yeah, yeah. I am unable to hear. Please
Yeah,
repeat question.
I was asking.
Huh?
Ma'am, can you please switch over? Just a second, sir. We are having a little echo issue from the same
Huh?
room.
Huh?
Yeah, am I audible now, sir?
Yeah, yeah.
Yeah. So
Absolutely.
I was asking, would you like to conclude something and then we will throw it open for the questioning, or the students can interact in between, because the questions have started coming from the students. So because we are
Huh.
almost towards the end of the session, so the way you
I
would like to
understand.
go
I
ahead.
understand. What I will
Sure.
do, I will go
Sure.
through few slides, and then
Sure.
we'll conclude. It's a not
Sure,
many
sir.
slides, and then we will
Sure,
have
sir.
a session. Give me
Sure,
some
sir.
time.
Sure, sir.
Thank you.
Sure, sir. Sure,
Thank
sir.
you. Okay. So now, can you see? Can you see?
Yes, sir. Yes, sir. We
Okay.
can. Yes.
Okay. So now many references indicate that iron production began somewhere between 1200 BCE to 300, but in Allahabad, UP, it shows the iron making was 1800 BCE. Now, these are actual proofs of coming from our archaeology. So, you cannot doubt this. The Iron Age in Europe started sometimes in 8th or 6th BCE. So, in India, we were thousands of years ahead of them. This development shows that India was industrially developed nation leading to the world in metallurgy, which was an essential base for forging weapons. Curious? Everybody would be curious. So these are some of the things. If you want to read, you see it is there. It is described in Brihad Vimana Shastra. This is written by Maharshi Bharadwaj. It is available and you can see many things like how crucibles are made. Then how installations of air blowers are taken place. They say that there are 514 sub air blowers. They were charging coal. Remember, at that time, knowing coal, this is not the coal made from the wood. It is a coal coming from the, coming from the earth. So they were using that kind of coal. There were bellows, you can see bellows were 532 types of bellows, they are described. There is a gold extraction. You can see that all this is available. You can actually now read it. Metals for aircraft were made. Now we don't know whether the people were able to make aircraft. Nevertheless, the description of metal that is given for aircraft, it is really matching with what we do today. These are heat bearing, heat conducting, heat proof, shining, acid proof, toxic, that is weapon grade, non malleable, fire proof, weight proof, that is very low weight, cold proof, poison proof, that is anti-toxic, acid proof, alkaline also, toxic, etc. So this is the description of the metal. So alloy making was also available in India. Bharat was called Sone ki Chidiya. The country was so rich that it attracted all good and bad people around the world. You can see, you are aware with this. Sultan of Ghazni attacked on border of Bharat, only border of Bharat, and looted Somnath temple 17 times from 1000 CE. It was good enough to run his country for 26 years. So a very small part of our country allowed another country to survive for 17 years. So this temple is just a very small part of our country. There are thousands like this. So you can see how much India had wealth in terms of everything that you can say. This was a graph which shows what was the GDP in India around that time. Turns out to be 35%. 35% of the world production was done in India around 0 CE, that is 2000 years back. Before that, it could be even much more, 70-80%. Now, what I will do, I will only refer to this particular aspect to show that India was trading through sea. Okay, this is to show that it was trading through sea thousands of years back. And this is another, the person, you know, Vasco da Gama. This is his travel path that he took. The adjoining picture shows route he had traveled. The route is an indication of the capability in navigation. He swayed away on several instances due to the lack of accurate calculation. You can see he started from here, he was close here. Now you see this distance is very big. This is Africa. He went somewhere and he was lucky to be here. He came here. He didn't know how to reach Bharat, India. From Zanzibar onward in Africa, he followed a Gujarati trader named Chandan to reach Cochin. The Indians had far more accurate navigation system because of development of mathematics. So remember, mathematics was the need of our navigation, and India was able to navigate in sea easily because of the very good mathematics. So there are few slides which actually tell us about the mathematics. I will not go into details of all of them. but I will just mention one here about the Surya Siddhanta. The Surya Siddhanta, it estimates the radius of Earth within 1% accuracy. Surya Siddhanta, according to some, it is 6,000 years old. According to some, it is 500 BC. Nevertheless, it is older than any of the Greek people who claim the Earth is round. In Surya Siddhanta, already the Earth radius within 1% accuracy was detected. Then you can see how year was measured. Year measuring started from 6778 BC. It is called the epoch of 28th Krita Yuganta. Epoch is a kind of situation in the universe, for example, particularly in our world here, that when all the planets come into one particular line in a particular nakshatra, then it is called as a yuga, as a epoch, and it happens somewhere around 4 to 5,000 to 6,000 years period. Now, all others, probably you have learned about Greek astronomers in 147, 127 BC and so on. They had trigonometric tables, but all these trigonometric tables were very inferior to what we had earlier in Surya Siddhanta. You can read about Surya Siddhanta. Surya Siddhanta also gives you radii of all the planets. It gives distance between Earth and Moon and Earth and Sun and all other planets. So it is, you can understand how developed the astronomy was in India. So all these calculations do go through. In fact, the average length of sidereal year, it is 365.2563627 days, which is virtually same as modern value here. So you can see how accurately they have calculated the time required to go through a sidereal year. There are one is tropical year, one other is sidereal year. You can certainly find it. Tropical year is one which depends upon the position on the earth, whereas this one depends upon looking at the different nakshatras. Anyway, so these are the things. Our mathematics was highly developed. The Fibonacci sequence was already given by who was the person there? Matra Meru. So by Pingala it was given 2,500 years ago. So it's a fantastic. You should go and see what our people had done. This Sri Yantra is one of the meditation yantras, and you can see in order to create it, a computer will require 10 raised to 17 steps. Computer, it will require 10 raised to 17 steps in order to create a good Sri Yantra. So that was the kind of geometry development. Aryabhatta is there, and there are many other things, like even the differential calculus was already present in India. It went from south in 14th, 15th century to Europe, and Newton and Leibniz, they saw it. Actually, that is what people say. This, I have given here a reference of C.K. Raju, who discusses about it. So Bharat has a very highly progressive country in past. Our progress was somewhat stagnated during Islamic invasion and British colonization. Today we are again reclaiming our position in the world. And who will make it possible? You. So I would urge that all of you should think that you are great people. Your ancestors were great, and you will do great things. This is only the last slide that I want to show. This is a comparison between two technology institutes. One is MIT. You know MIT, Boston. Please excuse me a moment.
Students, you have any questions in between? You can ask questions. So sir is having some call. So for next 5 minutes, we will take questions and we'll then move to the session. So students, those who have questions, you can go ahead.
All right. I'm in. Hello?
Yes,
Hello?
sir. Yes, sir.
Okay. Go ahead. If you have question, now you can have this slide. Please take a look at it, and the difference between the two slides. Above declarations by two technology teaching institutes show the difference in the attitude. One is saying, one is taking pride in creating jobs. Another is taking pride in having package for our jobs. You you decide on which side you want to be. Okay, I am done. Thank you. Thank you.
Thank
Namaste.
you, student. Thank you, sir. Thank you so much, sir. So, students, you can ask questions. Am I
Yes.
audible?
Yes. Go ahead.
Students, I think no questions.
Hello.
Hello, students.
Any
Sir,
question?
yes, sir. One
Hello, sir.
student asking. Arjun Dahiria. He asking, sir, how to become scientist in ISRO.
Huh. ISRO normally it has its advertisements given. Or you should on the lookout. Also, ISRO has some centers in different universities. For example, in the university where I work, it has it has a center. If you inquire at those centers also, they will tell you where to apply. But normally it does come, and it comes into very, normally highly circulated papers, newspapers, I mean.
Sir, what are the
Yes, sir.
depth of internships or research that we should take part in or even at least study to be able to call ourselves ready so as to join DRDA or ISRO?
First thing, most required thing is a very good understanding of basics. It doesn't matter what project you do, you are in your final year or so. Or, what is more important is they look for your basic understanding in your subject. It doesn't matter which subject it is. You may be doing mechanical engineering, electrical. You may be doing computer. It doesn't matter. But basics should be absolutely clear. If you are clear with your basics and your its relation to the basic science is clear, normally you will be accepted anywhere.
Thank you, sir.
Thank you. Thank you, sir. And
Yes.
students, you can ask questions.
Sir, hello, sir. I want to ask about what can individual can pursue regarding chemical engineering in future, so he can get financial success. Uh,
Chemical
like an startup,
engineering,
I'm talking about like in a startup regarding chemical, so an individual
absolutely.
can get success.
There is lot of scope for chemical engineering, particularly if you try to connect your chemical engineering with food industry, because there is a lot of upcoming projects on food industry. If you connect if you learn about chemical industry and connect it to food industry, it is going to be very beneficial.
Thank you, sir.
So, any
Yes.
questions? I think no
Okay.
question
If
from
there
the
are no
student side.
questions,
So, thank you, sir. Thank you. And we are grateful for your time and efforts you
Hello,
took to
sir.
share your experience. And thank you so much, sir. So,
namaste.
students,
Thank you, sir.
Thank you listening me
sir, one question
patiently.
from, sir, sorry, sir. One
Okay, go
question
ahead.
from Nitish Kumar. Can
Yes,
CS
Nitish.
engineer join ISRO?
Is what?
Can CS computer science engineer join ISRO?
Oh, yes, absolutely. They require people from all faculties, all kind of engineering, all kind of sciences. They require everyone. Don't
Okay.
worry. Absolutely.
Hello, sir. I have
Okay.
a question. Am I audible?
Shivam. Yeah, Shivam. Is that
Yes.
right?
Yes, sir.
Go ahead,
What are
Shivam.
some underdeveloped technologies in India which we should focus on?
As I said, the Fab Lab developments which are required, then we require some basic production in silicon itself. That is another requirement. Then these are some of the underdeveloped, where we need to focus. Okay. Then we need to go into uh, high computer power, So fast computers. Today we are only have about 5 tera. What is that? PFSI, something like 10 raised to 15. Okay, but 10 raised to 15 instruction per second. We have to be much beyond that. So those things are, that is where we are required.
Thank you, sir.
Okay, thank you so much, sir.
Okay, thank
So
you. I hope you will certainly follow some of the things I talked to you. Thank you,
yes,
students. It
sir.
was it was
Sir, just
for
a
me to
quick
talk to
comment.
you.
मैम आपने volume off कर लीजिए. Just a quick comment, sir. Thank you so much for taking your time from your busy schedule and to interact with our students. Can I assure on your behalf the students that if they need your guidance, they can have your email ID for the interaction. I mean, that way.
By all means, you are very
Yeah.
welcome.
Thank you so much, sir. Thanks a lot. Thanks once again.
Thank
Bye
you.
bye. Bye bye.
Bye bye, sir. Okay, students, we are going to have the next session. 5 minutes break. You can just take a break of 5 minutes, and we will be having a session on universal human values, and that will be chaired by Professor Shivam Dubey. Okay, and that session is directly mandated by AICTE. So AICTE has provided us with the video lectures that we are going to play with you, and you can enjoy that lecture. This lecture, ये जो lecture आने वाली next lecture है, lecture नहीं, that is a sort of video demonstration. This video will be sort of, मैम आप कुछ present कर रही हैं, so you will be presenting that. ओके, अच्छा आप साइन आउट कर सकते हैं शिवम सर. शिवम सर